What is compound interest? Compound interest or compounding interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. Thought to have originated in 17th century Italy, compound interest can be thought of as an interest on interest and will make a sum grow at a faster rate than simple interest, which is calculated only on the principal amount. How compound interest works? Compound interest is calculated by multiplying the initial principal amount by 1 plus the annual interest rate raised to the number of compound period minus 1. The total initial amount of the loan is then subtracted from the resulting value. Compound interest equals the total amount of principal and interest in the future or future value less principal amount at present or present value. Conversion period, the time period during which an investor can exchange a convertible security for common stock. What is number of conversion period? The time period after which the interest is added each time to form a new principal is called the conversion period. When the interest is compounded half yearly, there are 2 conversion periods in a year, each after 6 months. The nominal interest rate, also known as annualized percentage rate or APR, is the periodic interest rate multiplied by the number of periods per year. For example, a nominal annual interest rate of 12% based on monthly compounding means a 1% interest rate per month or compounded. A periodic interest rate is a rate that can be exchanged on a loan or realized on an investment over a specific period of time. Present value is the concept that states an amount of money today is worth more than that same amount in the future.
These are the formulas. IC is compound interest, P is present value of F, R is annual interest rate, T is the time per year, F is compound amount or maturity value, M is the conversion period, N is the total number of conversion periods, and I is the periodic rate. Example number 1. Matt is saving for a new car. He invests 5,000 into an account that pays 3% interest a year and is compound monthly. So how much will he have after 5 years? We are going to use our compounded formula. A is equal to P, 1 plus R over N and T. So P is equal to 5,000, R is equal to 0.3, N is equal to 12, and T is equal to 5. If we plug all in, A is equal to 5,000 times 1 plus 0.03 over 12 parenthesis 12.5. So A is equal to 5,000 times 0.03 divided by 12. This is equal to 0.025. Now, if I add that to 1, I end up with 1.0025, and this is to the 12 times 5 power or 60 power. If you take 1.0025 and you raise to the 60 power, this is equal to 1,1616 multiplied by 5,000, and the amount in your account is 5,808.08. Example number 2. Mr. Jefferson purchased an antique statue for $450. 10 years later, he sold the statue for $750. If the statue is viewed as an investment, what annual rate did he earn? If we view this as an investment of P is equal to $450, then we know that the future value is A is equal to $750. This was after 10 years. Finally, if we assume an annual rate, we will use M is equal to 1 and have A is equal to P times 1 plus R over M MT. 750 is equal to 450 times 1 plus R over 1 times 10. This is the same as 750 is equal to 450 times 1 plus R over 10. We are solving for the rate. R, we will use the following steps. Divide both sides by 450. 750 divided by 450 is equal to 1 plus r, 10. Simplifying the left-hand side, but we need to be careful about rounding, so we will keep the fraction for now. 5 over 3 is equal to 1 plus r over 10. Take the left-hand side to the 1 over 10 power to clear the power of 10 on the right. 5 over 3, 1 over 10 is equal to 1 plus r. Calculate the value on the left and solve for r. 1.0524 is equal to 1 plus r. 1.0524 minus 1 is equal to r. 0.0524 is equal to r. Therefore, Mr. Jefferson earned an annual rate of 5.24%. Not bad, but there was definitely some more complicated algebra involved. In some cases, you may even have to use of logarithm. A common situation where you might see this is when calculating the doubling time of an investment at a given rate. Example number 3. If you deposit 4,000 into an account paying 6% annual interest compounded quarterly, how much money will be in the account after 5 years? Plug in the given information. P is equal to 4,000, R is equal to 0.06, N is equal to 4, and T is equal to 5. Use the order or operations to simplify the problem. If the problem has decimals, keep as many decimals as possible until the final step. Then, round your final answer to 2 decimal places. FV is equal to 4,000 times 1 plus 0.06 over 4. FV is equal to 4,000 times 1.015. FV is equal to 4,000 times 1.3. FV is equal to 5387.42. After 5 years, there will be 5,387.42 in the account. Plug in the given information. FB is equal to 8,000, P is equal to 5,000, R is equal to 0.06, and N is equal to 12. Use the order or operations to simplify the problem. Keep as many decimals as possible until the final step. Divide side by 5,000. Take the logarithm of each side, then use property 5 to rewrite the problem as multiplication. Divide side by log 1.005. Then use a calculator to find log 1.6 divided by log 1.05. Finish solving the problem by dividing each side by 12 and round your final answer. It will take approximately 7.9 years for the account to go from 5,000 to 8,000. Example number 5. If an amount of 5,000 is deposited into a savings account at an annual interest rate of 5%, compounded monthly with additional deposits of 100 per month, the value of the investment after 10 years can be calculated as follows. P is equal to 5,000, PMT is equal to 100, R is equal to 5 over 100 is equal to 0.05, N is equal to 12, T is equal to 10. If we plug these figures into the formula, we get total is equal to compound interest or principal plus future value of a series. This is what happens. So, the investment balance after 10 years is 23,763.28.